There are hundreds of ancient monuments in Rome. But to engineers, one structure stands above all the others. It is the Pantheon. Over 170,000 tons of concrete were mixed during its construction. 16 40-foot granite columns shipped intact from the quarries of Egypt. It took 7 years to build, and it stood for 1,900 years.
It's extraordinary because it is the largest unreinforced dome from antiquity. It's also the best preserved monument from antiquity.
It's also the culmination of centuries of experimenting. When it was first constructed, its exterior walls gleamed white and its roof was clad in bronze. But this is why people travel thousands of miles to see the Pantheon.
Just look at the scale of that dome.
The interior is the same height as the Statue of Liberty, 142 feet from the floor to the top of the dome.
What makes the Pantheon such an extraordinary piece of architecture is its simplicity. It's a very pure shape. It is in plan a circle of 142 foot in diameter. And in section, it is 142 feet high with a dome at the top half. And it is like that because you could then fit a perfect sphere within the building. And there's something about the human eye that we find this simple, pure geometry incredibly pleasing and incredibly rewarding. Strip away all the decoration and fundamentally you are inside a perfect piece of built mathematics. This entire building is about this incredible interior space.
It's just an incredible building. But what's great about it is it's all structural engineering. It tells its own story.
The dome is half as wide again as the dome of the U.S. Capitol. It spans 142 feet and it's made of unreinforced concrete. And this is the genius of the Pantheon. The dome weighs 5,000 tons. It's not buried into a hill and it's not surrounded by a palace. It stands alone in the middle of the city with only its circular walls for support.
What we've got here is this massive weight that's bearing down at this arcade level here, the top of this arcade level. And what that's doing is it's creating huge vertical forces that have to be transmitted down to the foundations by lots and lots of structure. But they've beautifully hidden it in the walls.
The real work is done by 8 strong points or buttresses. They carry the weight, and that means that the gaps between them can be opened up.
They're made into usable spaces all the way around the perimeter so that you get this sense of this incredibly massive dome sitting on a light structure.
It's a brave move, stripping away all the parts of the structure that aren't necessary. But it's only possible because the engineers were certain that the weight was kept off the walls and channeled down into the strong points. A trained eye can see how it was done.
You can see, looking at the outside, some of the internal structures poking through to the outside skin. What we've got here are these huge relieving arches, about 40 or 50 feet spans.
This structure is far stronger than an ordinary brick wall. The arches are built into the brickwork. If they weren't there, traveling all the way around the drum in which the dome sits, the whole thing would come down.
These relieving arches are doing their job. Their intention is to transfer the huge compression forces from the weight of this massive structure down those buttresses and protect some of the weaker areas of structure below.
So if the Pantheon looks simple, that's because its design is highly complex. It was made by men with limitless resources who knew this kind of building. Chris Carroll, though he's a doctor of engineering, has never built anything like this.
This is by far the most complicated thing I've ever built. And with the Pantheon, there's a lot of different aspects you have to take into consideration. the way that we did it was just with the formwork and created the shape of the arch.
Chris's carpenters made a wooden mold to hold the concrete. The Pantheon's walls are 100 feet high, but the plan is to sit this dome 4 feet above the ground.
Looking good.
Chris has simplified the design for his building. There are no buttresses here, just a thick, continuous wall.
Break it up, Henry.
Here, hit it that way, and you get the better. Does that look better?
The Roman way of doing this was to build 2 brick skins, and as they rose, fill them with concrete. Walls on this scale aren't a problem, but the dome is a challenge.
If you think about it, with a dome, it's basically an arch that is 3-dimensional, and it all tries to compress at the top.
This dome is going to need a large amount of wood to support it. During construction, the interior of the Pantheon must have been a forest of scaffolding. The fact is, no modern engineer would build a dome as big as the Pantheon without using metal reinforcements. But the Romans just had concrete, and that meant they had to be clever.
The wall has a concrete core, but the aggregate changes as you go up. So it gradually gets lighter, in fact all the way through the dome too, and it's basically layered like a cake.
The trick is to manipulate the concrete mix. Near the base, it uses a heavy stone, travertine. But then it changes. It gets progressively lighter, so that the top section is made with pumice, a volcanic rock filled with air. Finally, the dome gets thinner, from 19 feet at the base to just over 5 feet at the oculus.
What they've done is, where they need the mass for gravity, it's big and heavy at the base, but where they've got these huge spans, they've made the structure a lot lighter. And that's really an intelligent way of dealing with things structurally.
The Pantheon's dome is a piece of precision engineering that has stood for 19 centuries. The Louisiana version is brand new, a great deal smaller, and a little simpler. But they're both built according to the same principles. So just how strong is this design?
I have an idea of how it's going to feel, but we'll see. I mean, it doesn't always go as planned.